So this is one of our smart agents. It works on Facebook, and this is a page that we have provided them. What we're going to see is placing a comment within the Facebook page, and the smart agent will be able to answer that inquiry that the user is making. So after refreshing a little bit, we can see the answer. So behind all of this, as you may persuade, there is a RAG connected enabled AI agent. This agent is prepared with most of the documents and directories of the scientific and science centers in Mexico. So it could answer any kind of a question about those documents in a public place. And we are honing this up with using graph databases in order to have more traceability for the answers that it's making, right? So we can connect this almost in anything. So what we are going to see here is the same agent but connected to the WhatsApp API. So we got an agent answering things within within WhatsApp. It's a very popular kind of application for commerce and business. But we are trying to make it more reliable, putting some kind of data motors behind it that could leverage the power of graph databases. And yes, at some point, knowing within full uh, the full examples of what people are saying, like in a swarm, and trying to connect ideas within them using our AI agents. So here's only answering questions using the common vector databases. And what we are going to do is to make it more reliable with graph databases. So those kind of engines of recommendation could be set up like really easily. And the trick is to massively send communication between pairs within a cultural or social network. So for example, we are trying to make it within a city. So for example, the smart agent is also connected to WhatsApp. So I'm here calling our famous Dr. Karopoulos. This is the character that we are using to showcase these smart agents publicly within the scientific scope of Mexican researchers. It takes a while, but he can answer in English, so it's really connected to an LLM. We are using LangChain, I believe, in this part of the project. And here we are going to make a question that is more related to the necessities of the information that some scientists will need in Mexico. And we are thinking in science in the broader scale, not just the projects of the scientists, but the projects of the nation. So, for example, we are asking here, how about the projects of putting a synchrotron, and it answers what it has in their memory. And I think that's it. And here is a result of interconnectedness. We are using the same agent, but now in Telegram. And even though it has the same database of knowledge, it has different kind of personality. So we can combine database knowledges and personalities with different agents. So that broadens up the scope of what we are doing, and it will make it more digestible to the public in general. Okay, so finally we have the graph databases that we can use. Here's a small sample, just 25 hits of the different data points that we have. We can try to reach for more. It's going to take a while, so have to stay tuned a little bit. And after that, we can see more about the complexity of the whole database. So here's a universe of points that we can use, and we can see the relationships. Here are some simple relationships that we can see. These are the simple relationships, and we can also see the complete landscape of the full network. So here is the complete network with all the data points that we can see, so we can zoom out. This network is a complete RAG and graph database that interchanges all the information for scientific knowledge in Mexico.